Guys, in this video, we will discuss about how to find the maxima and minima of a single variable function. So here we consider a function y is equal to f of x, and here we have to find the maxima and minima of this function. So first we have to find the dy dx, and then we have to solve the equation dy dx is equal to 0, and solving this equation dy dx is equal to 0, we get some points, say x1 x2, and these points x1 x2 are known as stationary points. These points are known as the stationary points, and then we will find the second order derivative of the function, that is d2y dx2, and then we will check that suppose at the point x equal to x1, if d2y dx2 is less than 0, then the function f of x contains maximum at x equal to x1, and if d2y dx2 at x equal to x1 is greater than 0, then f of x contains minimum at x equal to x1. So now the question is that if suppose at a point x equal to c, the second order derivative where c is the stationary point, if is equal to 0, then how can we find the maxima and minima? So we will discuss it later. So first let us take one problem regarding this first two condition, where at a point x equal to x1, the d2y dx2 is less than 0. That means the function contains the maximum, and at x equal to x1, if d2y dx2 is greater than 0, then f of x contains the minimum. So let us try to solve one problem regarding this. Then we will discuss about this point when the stationary point when at the stationary point the second order derivative is equal to 0, then how can we find the maxima and the minima of a function? So let us see. So see here we consider one function f of x is equal to x cube minus 6x square plus 9x plus 7, which I give as number 1. So then first we have to differentiate with respect to x. This is very simple, that is f dash x is equal to 3x square minus 12x plus 9, and again differentiating we get f double dash x is equal to 6x minus 12. So and now this two steps differentiation are very simple, and now for the stationary points we have to make f dash x is equal to 0, and here if we make f dash x is equal to 0, we get 3x square minus 12x plus 9 is equal to 0, and now if we more simplify it, we will get x square minus 4x plus 3 is equal to 0, and then after the simplification by middle term factor, we will get x is equal to 1 and 3, and now we have to check the second order derivative at x equal to 1 and 3. This will give the less than 0 or greater than 0. So now see that if we know that f double dash x is equal to 6x minus 12, and here we will check at x equal to 1, the value of the f double dash x is minus 6, which is less than 0, and at x equal to 3, that is f double dash x is 6 into 3 minus 12. From this relation we get that is the value 6, which is greater than 0. So now from the condition we can say that since at x equal to 1 f double dash x is less than 0, so f of x has a maximum value at x equal to 1, and the maximum value is at x equal to, we put x equal to 1 in the given main equation, and we find the maximum value is 11. And since f double dash x at x equal to 3 is 6, which is greater than 0, then we can say that the function has a minimum value. The function has a minimum value, and this at x equal to 3 is the minimum value, and the minimum value is 7. So I hope you understand. So next I will talk about another problem, which is, so let us try to solve this problem. That is, here we consider one function f of x like x to the power 5 minus 5x to the power 4 plus 5x cube minus 1. And see here the different, so we have to check that the function the maximum value and the minimum value, or we have to find here the stationary points. So see here we can say that we have to find the that at which point the function has maxima and minimum. So how can we find the maximum and minimum of this function? This is simple as the usual way, that is we have to first differentiate with respect to x. So here we find f dash x is equal to 5x to the power 4 minus 20x cube plus 15x square, and if we again differentiate, that is for finding the f double dash x, we will get 20x cube minus 60x square plus 30x. And now for the stationary points, we have to make it that f dash x is equal to 0, and if we make that f dash x is equal to 0, then from here we get that 5x square, if we take common from here 5x square, we get 5x square into x square minus 4x plus 3, and from here if we simplify, we get 5x square into x minus 1 into x minus 3 is equal to 0. And from here we can find the stationary points are x is equal to 0, 1 and 3. So now let us check at x equal to 1 and x equal to 3 what is the second order derivative. See here that at x equal to 1, the f double dash x, from this relation again minus 10, which is less than 0. That means at x equal to 1, f of x has maximum value. And at x equal to 3, from this relation f double dash x, we get, if we put x equal to 3 in this equation, we will get the value is 9, which is greater than 0. So now we can say that at x equal to 3, the f of x has minimum value. But now see here that if we put x equal to 0 in this equation, so here we get f double dash 0 is equal to 0. So now the question is that how can we say that the function contains the minimum or maximum at x equal to 0. So here there is no way that how can we find find the minima and maxima when the second order derivative at certain stationary points is equal to 0. So now let us try to find out that. So here I will just write one theorem or the one theory such that here, see that at x equal to c, suppose the second order derivative is 0, then the function f of x has a maximum if under the condition f dash c minus h greater than 0 and f dash c plus h is less than 0, whereas the h is a very small positive number. That means h tends to 0 and h is also a positive number. Then the function f of x has a maximum if it satisfies the condition f dash c minus h is greater than 0 and f dash c plus h is less than 0. In the similar way, we can say that the function f of x has a minimum at x equal to c if at the point x equal to c the second order derivative is 0. Then if that follows this, if this satisfies this condition, that is f dash c minus h is less than 0 and f dash c plus h is greater than 0, and where h is also tends to 0 and positive. So I hope you understand this two condition. You can note down it, and now we will discuss about that how can we solve this one. See here that at x equal to 0, f double dash 0 is equal to 0. So here we have to take f dash x, that is already we find from here that 5x square into x minus 1 into x minus 3. And so now if we put here f dash 0 minus h, so here what we get, that is 5 into minus of h square into minus h minus 1 into minus h minus 3. And after all, it will give 5h square into h plus 1 into h plus 3, which is greater than 0. And now we will check that f dash 0 plus h. So f dash 0 plus h, this will gives us 5h square from here, 5h square into h square minus 4h plus 3, which is also greater than 0. And see here that there is no changes of sign from f dash 0 minus h to f dash 0 plus h. These are both are greater than 0. So we can say here that x equal to 0, the given function has no maxima and no minima. The given function has no maxima and no minima. See here we get that both the functions are greater than 0. If both the functions are less than 0, also we can say that the function has no maxima and no minima. If there is only changes of sign from f dash 0 minus h to f dash 0 plus h, according to, if this is, as we tell here that f dash 0 minus h is greater than 0 to f dash 0 plus h is less than 0, then we can say that is the maximum function at x equal to 0. And if f dash 0 minus h is less than 0 and f dash 0 plus h is greater than 0, then we can say that at x equal to 0 the function has a minimum value. So see here that there is no changes of sign here, so we can say that at x equal to 0 the given function has no maxima and no minima. So I hope you will understand that how to find the maxima and minima, and if there is any, and so thank you.